Antiderivatives involving inverse trig functions. You must have noticed that if we differentiate sine inverse of x on a, it results in 1 over the square root of a square minus x square. Hence, if we integrate this expression, we expect to get sine inverse of x on a. Likewise, if we integrate the expression negative 1 over square root of a square minus x square with respect to x, we expect to get cos inverse of x on a plus c. And if you've got an eye for detail, you must have noticed this is no longer 1 over a square. This is a over a square plus x square. Integrated with respect to x will result in tan inverse of x on a plus c. Let's look at a few examples over here. Finding the integral of 1 over root of 1 minus 9x square. Now, if you recall our original form, in the original form, the coefficient of x square is negative 1, but over here it's negative 9. So we need some rearrangement. So I factor out 9 and I get 3 into square root of 1 over 9 minus x squared. Now I'll use these results and rewrite this integral as 1/3 times the integral of 1 over this expression, root of 1 over 9 minus x squared. Now from here, the value for a is actually, the value for a is the square root of 1 over 9, which is 1/3, right? And if I divide x by 1/3, I actually get 3x. So this 1/3 times the result of the integral is sine inverse 3x plus a c. Now, let's look at a different example. Example 2, over here we're looking at finding the integral of 1 over 1 plus 4x squared. So once again, this resembles this particular form where we find the integral of a over a squared plus x squared with respect to x, and the result is tan inverse of x on a. So once again, some rearrangement is required over here, because over here you see the coefficient of x squared is 1, whereas over here is 4. So I need to factor out 4. If I do that, I get 4 into 1/4 plus x squared. Now I use that result. I rewrite this integral using this expression. So 1 over 4 times, right, 1 over 1/4 plus x squared dx. Now the important thing over here is that my a is actually square root of 1/4, which is half, but there is a 1 over here, whereas in the original form there is an a, so I need to introduce that half somehow or the other. So to do that, I introduce the half over here, which means I got to multiply the entire expression by 2 to get rid of this half, which cancels, which simplifies 1/4 into 1/2. Now I have got half times the integral of a over a squared plus x squared. This resembles the original form, therefore my result would be half times tan inverse of 2x plus a c. In this case, a is equal to half, and we get tan inverse of 2x because 1 divided by half will actually end up giving you 2x. Example 3 is a little bit different. In this case, we're finding the integral of 1 over x plus 2 whole thing squared plus a 9 with respect to x. Once again, this resembles the tan inverse result. So once again, we have to rewrite this expression so that it makes sense. So in this case, we're going to be using a u substitution. Let u to be x plus 2, so that we have x plus 2 whole thing squared plus a 9 will look like 9 plus u squared. I've just changed the order around here to make sense later on. Now I rewrite this expression using my u substitution, but if I introduce u, I got to find the derivative of u with respect to x and multiply it over here, applying the chain rule, and dx cancels, so I end up with finding the integral of 1 over 9 plus u squared du. Now in this case, the derivative of u of course will be 1, so du over dx is basically 1. Now from here we can see that my a, the value for a, the coefficient of u squared is 1, so that's fine. The value for a is 3, so I get, I don't have a 3 up there, so therefore I have to introduce a 3, and then to cancel that I have to multiply everything by 1/3, because 1/3 times 3 will give you a 1. Hence we end up with 1/3 times the integral of 3 on 3 squared plus u squared. In this case, a is 3, therefore our result is 1/3 times the tangent inverse of u plus 3 plus c. And the last step over here is we resubstitute or substitute back for u. U was x plus 2, so we replace u by x plus 2.